Hello, INDE6332. My name is Catherine Fudge, and I am the project manager for this week's assignment representing Group 6 Victory Lap Management. My fellow group members are Quincy, Matt, Syed, Nagasai, Abdullah, and Saikalian. First, I wanted to go through an executive summary. The purpose of assignment 4 was to create a complete bill of materials for vessel construction organized by major system. Our chosen project vessel was 34 feet, aluminum, single diesel, and half cabin. Vessel construction is comprised of 8 major systems: hull construction, propulsion system, electrical system, freshwater system, sanitation system, navigation system, anchoring system, and research equipment. There were 98 individual components needed to construct our project vessel with a total cost of just under $163,000. Hull construction consists of 4 major sections: hull, deck, cabin housing, and rudder. From online research, it was found that the typical weight for a 34-foot vessel was 10,000 pounds. It was assumed that the hull and deck weight was about 50% of the total vessel weight, 5,000 pounds. Since our project vessel is of aluminum construction, the hull, deck, cabin housing, and rudder will all be fabricated with aluminum alloys. Using online resources, it was determined that a spade rudder is most typically used on larger vessels. A spade rudder consists of 5 major components: the rudder tube, rudder bearing and collar, rudder stock, rudder framework, and rudder blade. Based on online research, the rudder was sized to be approximately 2% of the vessel's underwater lateral area. Exact rudder size will be determined after extensive modeling. The propulsion system has the following major components: engine, propeller, propeller shaft, fuel system, exhaust muffler, heat exchanger, and cooling pump. Through online research, it was found that to drive a 34-foot aluminum vessel with a single engine and half cabin to a speed of 20 to 22 knots, a 600 horsepower engine was needed. The propeller shaft is used to transmit energy from the engine to the propeller. To achieve a speed of 20 to 22 knots, the typical diameter of a propeller shaft is 4 to 6 inches. The length of the propeller shaft should be sufficient to accommodate the distance between the engine and the propeller, about 15 to 20 feet. The pitch of a propeller determines how far the propeller will move through the water in one revolution. A 24-inch diameter propeller was chosen, as this will provide efficient thrust at a 20 to 22 knots speed. Lastly, for a 34 to 39-foot vessel, a 200-gallon fuel tank is required. The electrical system is concerned with providing the vessel with the electricity and maintaining the fidelity of this electricity via various means of power system protection. The main components are the generator, inverter charger, main battery, and solar panels. There are also various supporting components like breakers, bus protectors and bus bars, and battery protectors that ensure the performance and health of the electrical system. A digital screen is also provided to provide an interface to exhibit system status and routing from sources such as shore power or solar panels. The freshwater system delivers water to onboard fixtures to support various needs, such as drinking, showering, and washing. Having a reliable and efficient supply of clean water is critical for comfortable and safe boating experience. The components of the freshwater system are as follows: water tank, freshwater pump, accumulator, faucet, sink, deck fill, hose, water filter, water heater, water treatment, shower, thermostatic mixer valve, shutoff valve, dampers, non-return valve, elbows, and T's. In vessels equipped with a single diesel engine, the integration of an accumulator in the freshwater system serves as a pivotal asset. The bladder accumulator acts as a reservoir of hydraulic energy, effectively smoothing out fluctuations in pressure within the system. The marine plumbing system consists of various components essential for waste management and fluid transfer. This includes a toilet for waste disposal, a holding tank to store sewage, and a macerator pump to facilitate waste transfer. Seacocks are used to regulate water flow, and deck fittings provide access points for fluid connections. Hoses are used to carry waste between components, and a Y valve offers flexibility and waste disposal options. Additionally, a valve gasket set ensures watertight seals. Together, these components form a comprehensive marine plumbing system, addressing sanitation, efficiency, and user needs on board the vessel. The Marine Navigation and Control System guarantees the security, effectiveness, and dependability of vessel operations. The SeaStar Teleflex Baystar hydraulic steering system kit is the main component that provides accurate and responsive steering control. The bracket mount angler compass is a useful addition to this since it provides dependable direction even in the event of electronic system faults. The Elite FS9 chop plotter combo improves the navigation system by providing precise course plotting and navigation. It is furnished with comprehensive maps, navigation aids, and contour charts. The system also has an EV150 hydraulic autopilot system pack, which allows autonomous steering along pre-programmed routes, freeing up the operator from continuous manual control. The Garmin hydraulic pump bundle for Reactor 40 autopilot system is part of the system, which supports the autopilot feature and ensures effective and seamless operation. Additionally, the rudder angle indicator indicates the current position of the rudder blade needed for precise execution of turning scenarios. Accurate speed measurements are provided via the integrated I-40 speed instrument with through-hull transducer, which is used to monitor vessel speed. For this 34-foot vessel, one anchor weighing 18 pounds was needed. A fluke anchor was selected since it is one of the top choices for sufficient holding power. One windlass was used for this vessel that accommodated a 5/16-inch chain. The windlass was a free drop rope chain combination powered by a magnetic motor. A chain was needed with a 5/16-inch diameter since it was recommended for a boat length of 34 feet. One rode was needed at a 1/2 inch since it satisfied the rule of thumb that is 1/8 inch for every 9 foot of boat. The vessel also needed one anchor safety strap, one anchor chain pipe, one anchor roller, and one chain stopper. Only one of each was needed for a 34-foot boat length. Only one anchor puller is needed to retract the anchor from the water. The vessel required one stripper bar for the chain connections to the anchorage system. Since there is one anchor, only one anchor bag is needed to store and prevent any unnecessary accidents. The 34-foot vessel required one mooring buoy at 18-inch diameter, which is sufficient for the vessel, and brake line anchor kit for proper functioning. So these are the results of our bill of materials. The hull construction had 13 individual components for a total cost of just over $45,000. The propulsion system had 14 individual components for a total cost just under $75,000. The electrical system had 16 components for a total cost just over $20,000. The freshwater system had 17 individual components for a total cost of just over $4,000. The sanitation system had 12 components for a total cost of just over $2,000. The navigation system had 12 individual components for a total cost of just under $8,000. The anchoring system had 13 individual components for a total cost of just under $5,000. And the research equipment had one crane for a total cost of just under $3,000. In summary, we had 98 individual components with a total cost of just under $163,000. This is just our complete bill of materials. I just wanted to show it on the slides for reference. In this slide, you've got the hull construction and propulsion system. In this slide, you've got the electrical system and freshwater system. And in this final side, you've got the sanitation system, navigation system, anchoring system, and research